I'm Mr. Wamsted. This is my room. Oh, hey y'all. I just wanted you to see how my shirt matched my mask, matched my hair. Felt like I really had it going on today. We've got a lot of little things to learn today. They're called the exponent rules, all right? So we've got to take these powers and we've got to put them to some variables. We're going to use pretty much all x's and y's today. And then we have to just kind of learn a lot of little rules. So I'm going to show you some video teaching those rules, and then we're going to go back to the digital classroom and we're going to go over some examples, and then we're going to get into do some work, all right? So yeah, without further ado, let's get to that. Let's get to that video. Hold on. See?
If you look up the laws of exponents online or in a math book, you'll probably see a long list of equations that looks something like this. Wow, that's kind of overwhelming when you see them all at once. But don't worry, we'll take them one step at a time, and you'll see that they're not that complicated after all. Okay, let's start with just the first two laws on our list, which should look familiar if you watched our video called Exponents in Algebra. They're just the two rules we learned in that video. You know, rules, laws, same difference. So you probably already know them. They simply tell us that anything raised to the first power is itself, and anything raised to the 0th power is just 1. And because we already know about exponents that are higher integer values, like x to the second and x to the third, that means we've pretty much got things covered, right? Ah, not so fast. And now you know how to handle any expression with a negative exponent. It's just 1 over the same expression with a positive exponent. X to the negative 1 is 1 over x to the positive 1, or just 1 over x. X to the negative 2 is 1 over x to the positive 2. X to the negative 3 is 1 over x to the positive 3, and so on. So what if someone asks you to simplify the expression x squared cubed, which means the entire x squared term is raised to the third power? Well, our law tells us that we can simplify that by multiplying the exponents together. See how it equals x to the power of mn, which means m times n? That means x squared raised to the third power would be the same as x to the power of 2 times 3, which is 6. Suppose we have the expression 5 to the third power divided by 5 to the second power. Our law says that we can simplify this by subtracting the exponents. Specifically, we take the exponent on the top and subtract the exponent on the bottom from it. If we do that, the simplified version would be 5 to the power of 3 minus 2, or 5 to the first power. These laws look kind of similar to the last pair. Just like before, the first one involves multiplication and the second one involves division. But notice that in these laws, the bases are different, but the exponents are the same. That's the exact opposite of the situation with the last pair of laws. It turns out that these laws aren't about simplifying exponents, they're about how you can distribute or undistribute a common exponent to different bases. The first law shows this group, x times y, that's being raised to the power of m, and it says that you can rewrite it as x to the m times y to the m. In other words, you can distribute the exponent to each factor in the group. And the second law shows the group, x divided by y, that's being raised to the power of n, and it says that you can rewrite it as x to the n divided by y to the n. In other words, you can distribute the exponent to each part of the fraction. Of course, these laws would work in reverse too, and you could undistribute the exponents if they're the same. For example, if you're given the expression x squared times y squared, you could rewrite that as the quantity x times y squared. And if you have the expression x squared divided by y squared, you could rewrite that as the quantity x over y squared. Here are two expressions that will help you see why you can distribute or undistribute exponents like our laws show. In the first expression, we have the quantity x times y squared, and that's the same as x times y times x times y. And the commutative property says that we can rearrange those factors like this, x times x times y times y. But look, we can simplify that into x squared times y squared, so that checks out. In the second expression, we have the quantity x over y squared. That's the same as x over y times x over y. To multiply these fractions, we just multiply the tops and multiply the bottoms, which gives us x times x over y times y. And that simplifies to x squared over y squared. So that one checks out too. All right, so now you know about the so-called laws of exponents. And there's a good chance that you'll see them explained in slightly different forms or different orders, or even using different terminology in other math videos or books. But the basic ideas will be the same.
All right, y'all. So I know that felt like a lot, but we're going to go back to regular class right now, back to the digital classroom, and we're going to cover the rules again and go over some examples, so other examples, so we can just kind of get them in our head. All right? So yeah, let's go do that. All right, y'all.